Okay, so course format. Okay, so course format. This is a little bit outdated, but essentially, what's going to happen is for every lecture, we're going to have a series of pre-readings. Those are kind of for your own edification. If you want to read them, definitely feel free to. You'll probably get more out of the presentation. However, if you don't have time, or if you forgot, or if you didn't have a chance to, we're also going to cover most of the lecture kind of within the slides itself. Usually, the pre-readings are more just kind of additional resources if you really wanted to, if you're someone who likes to not pre-read or take your own notes or kind of come into it having a good sense of what the lecture is going to be about. Those materials are there. Every lecture, we're going to be focusing on a key topic. And so the layout of that is usually we do a presentation, but then after the presentation, you'll have a chance to work on a series of workshops or actual coding problems where you're going to be implementing those concepts. For the working part for the part where you work on the problems, full stack advocates a process called pair programming, which means you always work with another person. And the caveat there is that you're always only one person is ever typing at a single time. So it's not like you two are just working independently and just happen to be sitting next to each other. One person is quote unquote driving, so that's the person who's typing, and then one person is navigating, so the person who's looking on. And the reason for that is because, and we'll cover this a little bit more in the next slide, but we've really found that to be a really great process for people to not just dive headfirst and start writing code, but also to kind of be able to kind of get a good perspective and think about the problem as someone else is executing, and you'll be able to catch things that the other person who's writing the code might not be able to, and vice versa. The workshops can be a bit long, and just know that they're not meant for people to finish them in every session. Usually what I do is usually we'll give people an hour to an hour and a half to work on it. During a time, myself, the fellows will be walking around. We'll be kind of getting a good feel for where everyone is. After the class is over, we always release the solutions to the problems so you can take a look at them. But usually, as the instructor, I'll have a good sense of kind of which problems are probably more challenging for folks and others. And I'll probably also do a really quick review at the end of class, so that we can have a light discussion on the problem and what the solutions are. And then when you go home, you can take more time to look at the solutions more in depth, to kind of work your way through it on your own timetable. Me and the fellows are here for help. In your in your Learn platform. I think on the bottom right corner, there's a small icon where you can do to select help or ask for help tickets, or they might move it to the menu bar up top now. But I've also historically found that raising your hand works just as good. So use whatever method you want. And then just to dive a little bit more on pair programming, it is something that we really strongly advocate, and I try to be pretty lax with most things, but with pair programming, I am a bit of a stickler in that if I see two people just typing in parallel, like I will make one of you stop typing. And one of the biggest reasons for that is because when you're trying to learn a concept, like diving headfirst is great for getting part of the knowledge, but really like true mastery of something, it means you're able to teach it or explain it to someone else, right? And so when you pair program, it's not just about let's just get to the solution. It's about making sure that both of you understand the concept. And so if either you or your partner do not understand the concept, we want there to be a conversation, we want there to be a dialogue where there might be situations in which one person might have to explain what they're thinking to the other person. And that actually really helps both people at the end of the day get a much better grasp of the content. Because we have several workshop problems, usually there's 3 to 5 problems per workshop. It's up to you and how you want to do it. Usually you can say, hey, let's switch who's typing and who's navigating every 20 to 30 minutes. You can also do it on a problem by problem basis. I'll just kind of yell out every 30 minutes, like, hey, if you haven't switched yet, time to switch. Although if you find your own cadence for switching that works better for you, i.e. on a problem by problem basis, feel free to do that too. We just want to make sure that not one person is always typing, or even worse, not both of you are just always typing. So yeah. And then in terms of the tools, I'll talk about it a little bit more once we get to the actual problem. I like repo.it if you ever used it before, repl.it. It's a really good, just on your like in Chrome, it's a good way to type in various languages. And the reason why I really like that is because you can also just copy the URL and paste it and share it to your partner. so that if you're typing on different computers, you will now each have a copy of the solution that you can both reference. So it's a pretty simple way to do that. Obviously, use the development environment of your choice. And then the other thing is every single workshop we switch partners because we want you to work with people with different coding and communication styles than you. Super huge. This is really, really important. At any large, rather than at any technical organization that you work on, if you're working on an engineering team, more often than not, like it's not just a bunch of people working independently. Like in most cases, especially if you're working on something really valuable, really meaningful, no single person can really handle or understand what's going on at all times, and you really need that team. And engineering, for better or worse, has a reputation for being kind of very quirky people, right? Like everyone has their own persona, everyone has their own style, and as you'll soon come to learn, despite this perception of coding just being a bunch of ones and zeros and binaries, it is actually extremely. You can take a lot of creative liberties with coding, right? If your job is to write a program or piece of software that does X, there's a million ways for you to get from 0 to X. And so the way that you do it might be different than the way that someone else does it, even through the implementation or even just stylistically. And so the reason why we also want to make sure that you work with other people is because as in a real engineering environment, you're going to encounter people whose coding styles are very different from yours. And a significant part of engineering is not writing your own code. It's reading other people's code and understanding what they did and being able to figure out, okay, how can I add to this process, right? Otherwise, you'll just be rewriting other people's code all the time, and it's not tenable, it's not practical. So we really, 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 emphasize the fact that you should be working with other people. Engineers, for the most part, at least in all the orgs I've seen, do not really work alone, right? Even when you write a piece of code, you always want other people to review it at the very least. So like it's not like a siloed, it's not a siloed occupation where you're in a room by yourself and you're just coding for 12 hours straight and no one talks to you or you can talk to anyone else, right? It is a very, very collaborative occupation, and we want to mimic that to the extent that we can here at Full Stack. Okay, so I'm not going to reread this slide for you. You guys can all do that. But just philosophically, what we really want to emphasize here at Full Stack is we want to give you as much hands-on experience as possible, right? We want you to get a sense of not just how to code, but what engineering is like. The things we'll teach you in this week-long process, it will teach you a lot and it'll give you a really good foundation. But obviously, like there's a lot more to learn, right? And and the expectations that you want to be a software developer, especially if you want to make a career out of it, there's a lot more self-teaching, self-learning things you have to do. And so at Full Stack, we want to kind of teach you how to learn, right? So that if you encounter a concept, the question isn't, oh, who do I ask? The question is, oh, how do I figure out what this answer is myself? Like the most experienced developers I know, like they're on Stack Overflow all day, reading other people's solutions, other people's work, and you almost need to learn how to search for certain problems. So engineering is not nearly as knowledge-based as other professions may be. Really, the idea is how the basics work, and no one can really prepare you for all the permutations of issues you come across. But we want to give you enough tools that if you come across any problem, you can probably figure out what's the best resource to go, how can I test this, how can I kind of get to a place where which I can resolve it, and you may do it completely different than someone else, and that's absolutely fine. And then lastly, it's also just to make sure that you also understand, like at a high level, like what all of this is, right? Like writing code in my mind has always been kind of like not level, but like it's like the lowest tier of like what it means to be an engineer, right? It's not just about oh, let me just type some letters onto a keyboard that does this and I'm done, right? It's about communication. It's about project management. It's about understanding the problem first. So much engineering time is wasted because people don't understand what they're actually trying to do. The problem definition, or problem or project definition in engineering is huge. And a lot of different groups and organizations and individuals do it wrong, right? They think, oh, I'm an engineer. I should just be diving in first, start typing code, and that's how I add value. When in actuality, as an engineer, the most important thing you actually learn is trying to figure out, okay, what can I solve? Can I solve it without writing code? Because writing code is always, in some ways, the most expensive option, right? one thing that you'll kind of get a sense of is here is that like whenever you write a piece of code, it's not just you write it and you're done. There's a very heavy, very expensive ongoing maintenance that's associated with any engineering work that you do, right? When you write code, not only does it have to work, but people after you have to be able to understand it. They have to be able to tweak it if they need to, and the organization has to support it. And so there's this whole kind of ecosystem around engineering, and we really want to make sure that you also get a sense of that too. Understand that at the heart of it, engineering's about problem solving, and that writing JavaScript or even coding is just a tool to get to that end. And then oftentimes it may not be even the best solution, right? But we leave that up. We leave that as something that for you to decide based on your own experiences. Community values. Once again, I'll cover this once, and I'll just kind of mention it. But like I guess we're all here to learn. Like we're all here for the same purpose, right? At the end of the day, there will be an assessment, but we're not in high school anymore. There's no grades. There's no pass fail, right? Like the point for everyone's goal here is to learn, and to the extent that we can create a warm, respectful, nurturing environment to do it, really benefits the entire community. All right. If someone kind of violates any of these, we'll say norms or values, it really makes it hard for the entire group to kind of focus on the task at hand, which is to learn, right? So if someone is being difficult, or if someone kind of steps outside of the boundaries, like I might talk to you in private, I might call you out, but at the end of the day, just kind of keeping your back in mind that at the end of the day, everyone's here for the same purpose, and to the extent that we can, let's just we're all adults, right? Let's just try to be as respectful as possible. Patience. I'll go through these because some of these I think are more applicative in a lot of different activities. So patience is very, very critical, especially when you're pair programming with another person. Everyone learns differently. Everyone learns at a different pace. And in engineering, you'll actually find out that sometimes the fastest or the first solution is very rarely the best solution. So being patient with somebody, and if someone's not understanding it, that's an opportunity for you to explain to them in a way that helps them understand it. Personally, what I've always believed is if I can't explain a concept to someone in a way that they understand it, that's a failing on my part, in a sense that I probably don't even understand it as well as I think I do. So take that up as something that's also reflective of you and your own grasp of the concepts. This is a kind of introduction to JavaScript class in a way, right? So at this point, just ask anything about computers, internet, JavaScript. I'll do my best to answer. I can't promise that I know the answer, but I can probably find out what the answer is, even if I don't know. But just feel free to pepper me with as many questions as possible. Sometimes it may feel like we're moving at a slow pace, and sometimes it may feel like we're moving too fast. But like I said earlier, one, we'll be here for a whole week, right? So we'll have a lot of time to adjust. And then two, let's say we let's just say we blitz through everything, right? We cover the entire curriculum by Wednesday. It's so what, right? The end, we're gonna get to our end goal, right? And so there's almost no need to rush the process. And in a lot of ways, coding is not something you can learn, or programming is not something you can learn academically. A lot of it is in the struggle of you trying to solve something and not being able to, and spending hours and hours on it. It doesn't sound great. It doesn't sound great, but every single person who I know has spent hours and hours doing what they thought were very simple things that took much longer, and that is part of learning how to be an engineer. Helping others, teaching others, and having fun, I think, just kind of goes without speaking. Once again, we just really want to be respectful of each other. And then on the topic of respect, I'll leave this up here. You can take 30 seconds to read through it. But we're fairly stricter at Full Stack. People come here from all kinds of backgrounds, and occupations, and walks of life. And really, there's no need for anything that would violate any of these norms up here, as an organization. The last one's also, just a good rule of thumb. If you're wondering, is this gonna sound racist or sexist or offensive? Just don't do it. For the most part, like I said, everyone here is an adult. You can kind of use your best judgment. If you had to ask, it's probably not the best thing. Any questions on any of these? Good? Great. Okay. Okay, so here, so we're teaching JavaScript here. So if you want to learn Python, this is the wrong class. But so why JavaScript? JavaScript is the most popular language in the world, and a lot of the reason for that is because of where it's used, primarily in the front end. And I'll explain kind of what that means later on. But just know that like JavaScript is by far the most commonly used language in most software engineering environments. Not and really at this point, it's probably the only kind of widely adopted front end language, right? So if you were to go to any website, right, usually what we define as the front end and the back end means you have a server, and then you have a client. I'll say, right. So let's say I want to go to Facebook or Google, right? Google has their own servers, or Facebook has their own servers somewhere else in Algeria or Norway or wherever it is, right? And when I access that website, there's what Google stores about how to run their website, and then there's what I see on my laptop, right? So basically, in that line, everything that kind of Google owns and Google kind of holds under there, we call it the back end. And then on the front end is everything that the user actually sees, right? In most cases, so the browsers that we all use are what, Chrome, Firefox, Safari, unfortunately Internet Explorer still. Like there's only like a few major browsers, and almost all of the major browsers run JavaScript as a front end, right? And so because of that, that's one of the reasons why JavaScript is so popular, is because if you want individuals to be able to communicate with your server and to see your site, usually JavaScript will be the language that you use. Recently, or not recently anymore, but about I think in the late 2000s, up until the mid to late 2000s, JavaScript was only a front end language, which meant that you would write your servers, you would manage your servers in another language, and then you would hire another team to come to the front end and write about like what I want, how do I want the user to see my site, how do they want to engage with the site, etc. But something called Node came along, I think in the late 2000s, that essentially also enabled people to use JavaScript to manage and write their backend as well. And so now JavaScript essentially became this full stack language where if you just knew JavaScript, you could theoretically create an entire site or entire application from scratch, right? You could write write what's going on in your servers in JavaScript with Node, and then on the front end you can write JavaScript to kind of manage what your customer sees. And so that's another reason why we teach JavaScript, is because it does kind of offer the greatest flexibility in enabling you to create as much as possible while knowing only a single language, right? So like if you were to use like Python, for example, right? Python's really good for managing stuff on the back end, but Chrome doesn't run Python. So if you were a developer and you only knew Python, it'd be really hard for you to kind of write something that works, that a customer can see. Yeah. Oh, sorry, I should have came here instead. And it's also very user friendly. Like JavaScript is, I would argue, so there's a distinction in computer science between like kind of higher level languages and lower level languages, and all that means is higher level languages are kind of, they abstract more away for you. So what that means is you're focusing on kind of just doing like the bare minimum, or not. I'm sorry, that was really poor phrasing. What you're really focused on is just kind of doing what you need to do, right? Whereas lower level languages are a lot more technical, and there's a lot more implementation kind of customization that you can do. And the reason why there is this distinction, one of my favorite concepts that I learned about when I was reading Java was this idea of garbage collection, right? So in JavaScript, if you create a or actually let's do memory allocation, right? Like that's a really interesting concept, right? So in JavaScript, let's say you have a list. You want to create a list of things, right? You have no idea how long it's going to be. You can really just say, hey, create an empty list for me, like var foo equals empty list or empty array, and you can walk away. And you can just keep adding things to that list until eventually your computer runs out of memory, right? You never worry about like how big that list gets. In a lower level language, what they would do is they would actually say, hey, when you declare the list, tell me how big it's going to be. And if you ever violate that list, you need to either make a new list or add more memory to that list. And so it's a lot more restrictive on what you have to do, on what you can do. But the benefit of that is that you get to control a lot more, right? You get to make your code really optimized, really efficient, because you can customize so many more details of it. So JavaScript, like Python and Ruby, are higher level languages, which means that they handle a lot of the management and the nuts and bolts for you. So you don't really see that. You just kind of focus on what you want to do. And in that way, it's also a very learner-friendly language. In that when you look at it, it's like, it's kind of like you get to do the fun parts of programming, if you will, without worrying about some of the more kind of gruesome details that are definitely very important, but may not be important in kind of what you're trying to do right away. Okay. A bit long-winded, sorry about that. Any questions? Yes?
What's an example of like a popular lower level language?
C is like the most popular one by far. Yeah. I mean, as an example, like higher level, or actually, I'm not gonna say that. I would say like lower level languages definitely kind of came first. And if you actually are really interested, if you like unpack JavaScript and look at like, I think JavaScript is written in C if I'm not mistaken. But really JavaScript is just like a nice wrapping for C. Like it takes a lot of what C does and just says, all right, we're just gonna make a bunch of assumptions and then let you do the fun parts, right? Like I'll handle garbage collection, I'll handle memory allocation, I'll handle all these different things for you. So lower level languages are by far like the fundamental computer science. But for this class, in terms of making you kind of a software developer who wants to build products, higher level languages kind of get you there a little bit faster. Any other questions? Yes?
Is React JavaScript based?
Yes, React is a JavaScript library, and we'll talk a little bit more about what libraries are. It's a Facebook library, I believe, and it is very popular, but it is written with JavaScript. Like it just, the way that JavaScript, it sits on top of C, like it packages up for you, React does that kind of for JavaScript. It makes a lot of assumptions for you. It just makes it really easy for you to use certain things. Yes?
I've heard like developers use PHP as a language. How do you combine PHP and JavaScript?
How do you combine PHP and JavaScript? You really shouldn't, but
I don't know
yeah.
actually.
Well, yeah. So I mean, PHP, like I said, PHP is just another language, right? Like all these, and PHP, I actually think is, yeah. So you can use PHP on the backend. You can also use PHP for templating, right? So with any, like, if you really want to kind of go down this rabbit hole, if you will, like, there's so many languages that you can use for various things. And PHP is just another option. It's another language that you can use. And once again, JavaScript, we just focus on JavaScript here because it is the more kind of the more commonly adopted one. And the other thing I'll talk about JavaScript too is you might come across a lot of different languages in your time as a developer, but you'll very soon realize that like more or less like two things. One, the concepts that underlie most languages are like 99% the same. Right, like the way that like a loop works in Python is the same that works in C, and the same way it works in JavaScript. The implementation might be different, the syntax might be different, but like the concept is still the same. So if you learn JavaScript and you're like, hey, I want to get a job that does Python or does whatever, or uses another language, it's not that difficult for you to translate fundamentally these concepts into another language. So languages, in my mind, are just kind of syntaxes, right? They're not, very few of them introduce any new concepts. And then secondly is, as you learn JavaScript, right? The reason why JavaScript is also really good is because you can actually just type it in Chrome and it works. REPL lets you do it, type other languages. But as I'll show you later on today, like you can open up any Chrome browser, just open up your developer tab. You can actually start editing things in real time. And it's a really good way for you to just kind of play around with things and get a feel for how things work. Any other questions? Yes.
Is React Native the same thing like React?
React Native is a separate library that takes mobile into account. So it's very powerful because it means you only have to build things. You only have to build an app. It should theoretically work on your iPhone and on your Android phone, and also on your website. But once again, it is JavaScript based. It's just another library or implementation of it.
So what you're saying is we can use JavaScript to build even mobile phone applications.
With React Native, yes. Yeah.
And it's not just for Facebook. Google is also investing a lot in React. Not like Google is going and programming and having to React, but Google is trying to get developers to use React because it is an easier way to do it. So it's not just the Facebook thing. It's also like Google is an advocate as well.
Have they given up on Angular yet, or
not yet?
Not yet.
I used to work on Firebase as well.
Cool.
Firebase we can talk
Yeah.
about later on, but Firebase is a platform that many developers use inside of Google, and it allows you to use a bunch of different languages to interact with it. React is one of the ones that most developers use, so Google's now saying, okay, well, we should invite everybody that uses React into the party. So there's a lot of investment.
Yeah, and just for everyone's context, like Angular was like React before React. Like Angular was kind of created by Google and it's championed by Google, and they kind of development for it. React actually came along like fairly recently. When I was a student here at Full Stack, I don't even think we taught React yet. When I was a fellow, we started teaching it. So it came around the past, like 3 to 4 years. But like I said, like don't get too hung up on different languages, different libraries, because these will come up every few months. Like every few months, if you read Hacker News or any kind of blog sites, people will talk about the next great framework, the next great library, the next great whatever, right? And if you're a developer, you're just chasing those fads, like you'll never get anything done, right? Like right now, what we're more about is like, hey, like let's just get the concept out of the way, because certain concepts are universal amongst all languages and amongst all libraries. So like get the foundations, and then once you feel good with that, if you have a very personal penchant for any library, feel free to use it. But for now, let's just focus more on the concepts. Like implementations they're honestly a dime a dozen. Okay. One thing that you'll come across is this, when people talk about JavaScript, they might talk about something called ES5 or ES6 or nowadays ES7. So JavaScript is a language, but obviously, we need we need a body to kind of govern what is JavaScript, right? Like someone needs to say, hey, this is JavaScript versus this isn't JavaScript. And so the people who do that is called ECMA. They're a organizing body, if you will, and they're the folks who usually publish the standards for what is JavaScript, right? Like, oh, JavaScript language supports doing this, but not this. Or if you want to create a variable in JavaScript, you say var, right? Or now in ES6, you would say let or const or something else, right? So all of that means that JavaScript is also an ever-evolving language too. And there are organizations whose entire job it is to say, hey, we want to add all these new features to JavaScript. Let's make sure that these features and these rules are universally kind of accepted, right? So ES5, ES6, and ES7 stands for ECMAScript in the 5, 6, or 7, which is just kind of the version of JavaScript that it's on, right? So, ES5 is what we're going to be teaching at Full Stack. ES6 is out, and then ES7 is more or less kind of on an ongoing release at this point. The reason why we're sticking with ES5 is a few reasons. One is 5 is kind of by far the most universally accepted from a technical standpoint, right? Think about it this way: whenever they release a new version of JavaScript, they're going to make some changes to the rules of JavaScript, right? And so a lot of orgs say, okay, I need to now look through my code, rewrite some parts of it, and make sure that's configured correctly. Similarly, if I'm Chrome and I run JavaScript, I now need to add some more rules, some more features that I now support. So there is a process for migrating from one version to the other, and it's often very messy and not very straightforward. But the good news is someone who takes ES6 will also definitely still accept ES5, right? Like they wouldn't just say, oh, we no longer support the old versions of JavaScript. So by that logic, ES5 is by far the most universally accepted form of JavaScript right now. In 5 years or 10 years time, that may no longer be the case. But the reason why we're saying ES5 is just because ES5 will still run in all the major browsers, including Internet Explorer. And it's also just something that you will see a lot more commonly at this stage, at this phase. But the good news is conceptually, like I said, ES5, ES6, ES7, ES8, even they're keeping the core concepts. They're just adding features to make your life easier. But I see that once again as more syntax changes than concept changes. So if you want to talk more about it, happy to. But just for now, at least, don't worry too much about ES6 or ES7. Cool. Any questions for that, or any questions around that? Ellie, you have a question? Oh, yeah. Cool. Okay. So getting the most out of this, and sorry, this morning is going to be a lot of me talking at you, so I apologize beforehand. But we just have to kind of get a lot of it out of the way. So JavaScript Jumpstart, I know that that you guys didn't have that much time to do it, And so what I'll actually do is, right like at the beginning of like right before lunch, what I'll do is I'll just do a quick kind of like in class like poll around how everyone felt about JavaScript Jumpstart. And then we can also talk about like if there's any concepts lingering from Jumpstart that you still had trouble with. And during lunch, I'll just look through and try to see, is it worth doing a separate review, or should we just cover that topic? Oh, I'm sorry. Or should we just cover that topic more in depth when we actually talk about it as a lecture? But okay. Okay. The second bullet, enjoy the productive struggle. That's what I was talking about earlier, where you'll spend hours and hours on something really seemingly silly or simple or dumb. And just know that every single developer has gone through that. It's very painful, but like that is how you learn. Like it just feels terrible when you're doing it, but then when you look back, I think you'll realize like how much more you've learned by doing that versus you just asking someone for the answer, right? And that leads to the third bullet, which is feel free to ask questions, but just I probably won't give you the answer. I'll probably just tell you how to find the answer, and it's not because I'm trying to be mean, but it's because that is how you learn to be a developer. The things I tell you, the slides that we have, they'll only take you so far until you start doing it. And once you start doing it, you'll just personally encounter a whole host of challenges and issues, and really how you navigate that is that's going to indicate your level of growth as a developer. So once again, we have solutions for you, but I'm personally this is not, like I said, this is not a thing you're being graded on. Like if you look at the answer, you know how it works, but you didn't try implementing it, then I guarantee you, if you see there's a similar problem, you're probably going to get stuck at the same spots. Like even if you do a problem, you try for an hour, and you're like, this is really silly, I don't know the answer, I can't get to it. Once you look at the answer, like even if the answer is right there, like try typing it through line by line so that you not just conceptual, like you can see how the code works, but try running it as you're typing it so you can kind of get the feel for, oh, if I was writing this myself, this is kind of how it will work. Like in most problems that you encounter here, they're not just like do A and then you're done, right? It's like you do 5 different things. And so really it's kind of like building a house, right? Like you put the foundations in, then you try and do you put the door, the windows, and then the roof, and then you paint the walls, etc., right? Engineering is very similar, right? Like very, very few pieces of software are ever written top to bottom, right? You always start somewhere, and then you add a little bit more to it, and then you're like, oh, maybe I should organize it this way, so you put it in and make a function, right? And then you kind of move things around, right? So it's a very active process, and even when you look at a solution, try to think about, okay, if I was to write this myself from scratch, what's the process for writing it? Because I guarantee you it won't be from line 1 down line 100 directly. Like it is, you are building up your framework for thinking about problem solving and how you would approach it yourself. And the last thing I'll say is, even though we're here like 100 hours over the next week or so, like if you really, really want to kind of get the most out of this, like you will just have to put a lot more work on your own time. Whether it be practicing, whether it be reviewing materials, whether it be building other problems. Like I can point you to literally a dozen sites that just have hundreds, if not thousands, of these problems you can just solve to really kind of measure where you are and really get experience. But don't only come to this class, do this class materials, and leave thinking, oh, great, like I know this. Like you just have to do and practice so much. And it's not because full stack doesn't want to offer you the resources too. It's just because it is one of those things where it's like, I can talk to you about how to swim, right? But unless you get into a pool, like you'll never conceptually know like what to do. Cool. Okay. Slack, learn.jumpstart. Good. Assume everything. Okay. Any questions on course basics, logistics, why JavaScript? Before we just do a really quick 10-minute thing on like some code styling preferences. Yes.
Do you have a recommendation for taking?
Alex.
Yeah.
Yes. Yeah.
Do you have a recommendation for taking notes, like a programmer interface to take notes,
Yeah. I mean, like a lot of like flame wars have been fought over like the best like note taking or both best code environment. I personally use Sublime to write code. But honestly, for anything I write, I have a Mac. I use TextEdit to write things. It's literally a blank piece of thing with zero customizations available, and in my mind, it actually helps me write really well when there's not so many features and distractions. But whenever I write anything programming, Sublime is my development environment of choice. But once again, that's purely personal preference. You use Evernote, whatever, like go for it. Like I don't really like have a stake in that. Cool.
Is there for Sublime, is there like a specific set of preferences you have in terms of like how it colors, whatever the like highlighting or whatever the different preferences are? Is there anywhere that we could go to find like, because I've used it some of the JavaScript stuff we did in whatever the Jumpstart thing, but it didn't feel like it was as good as some of the other options.
Yeah, so the question here is, Sublime is just it's basically like a text editor, right? But for programming languages, it will color code certain keywords in different colors and, indent for you in certain ways so that it just looks very clean. There's a bunch, there's Atom, there's, what's the other one? I mean, if you want to use Vim, like, feel free to if you really hate yourself. But like, there's like literally a bunch of like these different tools. And once again, right, just tools, right? Nothing more than that. They all do the same thing at the end of the day. They just do things a little bit differently. And then what Lewis is asking about is like, for the colors or the indentations or layouts, are there any themes that particularly good? I don't personally like have one that I like. If you just Google like Sublime themes, you'll come across so many blogs of people who have these themes that they really like, and they'll give you the settings. You can customize them yourself. In my experience, like I think if you do this for 20 hours a day for like several months, it may make your life like a little bit nicer, but like fundamentally, none of it really changes how I program or how I think about code. Yeah. Cool. Anything else? I'll also just wait for 30 seconds when I ask if there are any questions, because usually it takes people some time to get the courage to actually ask. Yes, Matt. No, bright, but like Brownman? Brownman.
Sometimes I watch YouTube videos.
Yeah.
I watch tutorials, but it can be really annoying to go from my editor to the video, pause the video, go back to the editor. Do you know if there's like?
What kind of computer do you have? You have a Mac. Can you not do this? Just like split the two screens side by side, or?
I can do it, but
okay.
I didn't know if there's maybe.
Oh, I mean, most developers I know, I don't personally for like personal reasons, but most developers I know use an external monitor. You guys all have them. Feel free to use them. I think most people have like the second monitor as like the code, and then their Mac as just whatever they're watching or researching at the time. But I do everything on a single computer, and like sometimes I do like you have different monitors. You do like the 4-finger swipe left and right pages, but yeah.
And also the keyboard shortcut, it's like Alt Tab back and forth.
Yeah.
You press spacebar for pauses YouTube, so you just spacebar Alt Tab back and forth, which
yeah. As you do this more and more, you'll pick up your own personal stuff, like things that you think really help. And I'm happy to share a few tools that I use probably maybe after lunch or something. But yeah, like the extra monitor might just be easiest for you if that's like what you're doing. Any other questions? Okay, cool. Oh, nice. It's only 11:30. Great. Okay. We're gonna talk about tidy code. Tidy code is, I guess, at the essence of it, it's a suggestion, but really, like, these should be rules. It's just like, like when you write a sentence to somebody, like I know like the way we text nowadays, like it's like its own like pseudo, like its own pseudo language. But really in programming, like you're as much coding for yourself as you are coding for other people. And the one piece of advice I would give is other people includes your future self. Because I've like looked at code that I've written and been like, I don't understand like what I did. Like, and it happens way more often than you would think. So if you have trouble thinking, well, if other people don't understand my code, they're just being dumb, trust me, you won't understand your code, and maybe it's you being dumb. But so when we talk about tidy code tips, like these are things that make your code just a lot more easier to read and a lot more easier to understand. it's very possible that your code will run whether or not you follow these guidance. But if you're thinking about engineering as a profession, especially where you're working very collaborative environments, it really, really is important that you follow, these guidelines to the extent that you can, because it makes a significant difference in terms of how accessible and how easy it is for you to focus on, I guess, more important things other than just trying to figure out what someone's doing. Yeah, so as an engineer, you'll probably spend more time reading code and debugging code than writing code. Very often, writing code is the easiest part of the whole process. Like it's like if someone was like hey, fix my car, and only the door handle was broken, right? Like it might take someone a long time to figure out, oh, like I just need to screw in the door handle and I'm done, right? But to do that, they might need to read the entire manual on the car, right? And that's how oftentimes a lot of code feels like too, right? So like you're doing something very, very simple, but you need to read and understand so much more before you do it, because you really want to make sure that you're not breaking anything else. And that breaking anything else part is probably by far the biggest reason why softwares most often don't work as intended, right? One person builds a thing that actually works really well and does what it's supposed to do, and there's no problem. Someone else comes on like, oh, hey, let me add one small feature, or let me fix one small thing. But they didn't read the previous person's work careful enough. And then when they incorporate their changes, now everything breaks, right? Any software application is just one big factory, if you will. Right? There's a lot of dependencies, right? A has to work so B can work. B has to work so C can work. And if you break any part of that process, you can take down a lot of things with you. So tidy code, once again, just cannot emphasize enough. Like it really, really makes a big difference. And I'll be honest, like yeah, and I guess just to that maybe the professionalism point, like even in job interviews, right? Like during interviews, like most interviewers care a lot more about concepts. I know I certainly do, but when someone writes good code, as an engineer, you kind of learn to appreciate it. Like, oh, this person, like he or she is very careful about the things that they do. That shows that A, they've clearly done this before, and two, like I would enjoy working with this person. And don't discount that second point, because like if someone's interviewing and they think I have to work with this person, like those things do matter in terms of how they evaluate you as a future coworker. Okay, so first one, indentation. One thing we'll talk about in this over next week is this idea of scope, right? But at a very high level, I think everyone who you've all dabbled a little bit in JavaScript, right? You understand that that indentation is very important because it tells you kind of where the block is, right? Or where this piece of code they're currently working on, where it starts and where it stops. And it makes tracing through things a lot easier, especially for humans, because these curly braces that you see up here, that define a function. Like when you nest like 10 or 20 of them in a row, which is very, very possible, like as a human, it becomes very hard to figure out where the breakage point is. And so indenting the code, even if it looks really crazy or indenting it very far, trust me, that is so much better than the alternative of you not indenting it and then having someone trying to figure out where this thing starts and where it stops. I don't like to read too much direct off the slides, so you can read the green text yourself, right? But just whenever you change blocks, if you're going in, you indent inwards. If you're leaving a block, you go back to the same indentation as the beginning of that block. Most tools like Sublime or Atom, they actually indent for you now. So if you tell it you're writing JavaScript, for example, and you write a curly brace and you hit enter, the next line should automatically be indented for you. And so it definitely saves you a lot of trouble in doing that. But that's not like a panacea by any means. Like especially when you're going through and editing code, if you remove this snippet and now this block's incorrectly placed, like the computer will do some of the work for you. But after you're done writing a piece of code, like read through it and make sure that make sure that everything, that all the indentations do make sense and that they do align. Because it does matter, especially if other humans are reviewing your work. It might run, but it doesn't mean that it's good code. Variable naming is another big one that's actually very, very critical. So JavaScript uses camel case, which means if you have multiple words in a variable, you keep the variable names should always start with a lowercase letter. And there are a few exceptions to that, but in general, they should always start with a lowercase letter, and then you capitalize each subsequent word, right? So in this one, like my favorite place, right? The F and the P are capitalized, but the M is not. If you're doing something on a one-off basis, something like var x is fine. But if you ever see var x in like a production database, like in someone's actual, like someone's running an app and they have var x in there, like that's a big red flag because no one knows what var x is, what it's supposed to be, and therefore they can't tell you if it's wrong or not, or where it came from, or kind of where it goes, right? So if I have a variable like my favorite place, like even though it's just I'm making a lot of assumptions here, right? I at least know, okay, it's probably a place, which tells me that it's probably also a string and not a number, right? I could be wrong, but once again, like these variable names are just good assumptions to make. And if I'm looking in the code base to figure out, okay, where does the value come from? If there are any functions that says like create my favorite space, I can then probably assume that it comes from there. So these are not like hard and fast rules, but the more explicit you can make your variable naming, the better. Because after a while, like trust me, like you'll get confused yourself around where certain things come from. If you just do var a, var b, var c, var d, like all the way through, like those ambiguous things, you may be able to keep track of in your mind for one or two, but at a certain point, you're just going to get completely lost. The one time in which it's fine to use shorter variable name is for loops, and the reason why is because the way that JavaScript in particular works is when you do things like var I equals 0, I dot da da da, like var, the I is kind of only defined within that. It's only used within that very, very limited context. So in that case, there's no need to say for loop counter, because when someone looks at code, they look and say, okay, this is clearly only used as a counter within the context of a for loop. So they use I. But even that's a bit dangerous, and we'll talk about why later on. But just know that conventionally that's fine. But if you're ever creating a variable, like you should be at least someone else should look at it and at least have a sense of what you're doing with it, or where it's coming from, or what its purpose is. Okay, cool. Okay, so that was it for just like the code tidying portion. So anything around that, and we can talk about other best practices too, if you guys have any questions about code that you've seen. But once again, these are things that like you'll just pick up as you're pair programming, especially because your partner's not going to understand what you're doing if you have bad code hygiene. And then when we kind of talk as a class about solutions, about problems, also just kind of inject some of that, kind of passively as well about best practices with coding. Any questions?
You mentioned there are some exceptions to this naming convention. What would they be?
For which rule?
Maybe the variable naming or something.
Which rule about variable naming?
You said we have to start with the lowercase, but
yeah.
In that way I use an array, and I was able to divide the array using the uppercase.
Yeah. So once again, all these code rules, like your code will more likely than not run fine if you don't follow them, right? You're doing this more for the other people who read your code and for people who understand, right? So the reason why you don't want to uppercase your code, or God forbid, write it in all caps, is because conventionally in programming, you do that when something you're working on is a constant. In JavaScript, there's not really this idea of a constant, right? So what a constant is normally when you define a number or a string when you create a variable and you assign a number or a string to it, the idea is, okay, right now it equals 6, right? I might add 5 to it, I might multiply it by 10, I might do something to it, and it becomes a new value, right? The idea for constants is like, usually like if a variable name is in all caps, it means that it's a constant, which means that once you create it, it really shouldn't ever be changed, right? Other languages are very, very strict about enforcing that. JavaScript is not. But conventionally, you'll still see that going around. And so what are some examples of constant variables that you wouldn't want to change? For example, if you're trying to access an API or an account, right, the username and password will be constants because you never want to change that, right? If you're trying to go to a specific website address, right, and you always want to go there, that would be a constant because you wouldn't want to change that. So normally, as a programmer, when you read through a line of code and you see a variable in all caps, it just means this variable was created with the intention of it never being changed. And if you're changing it, you're probably doing something wrong. Right? So, because these rules are not technically enforced, your code will run. You can define your own name however you want. It will work. But if I was to read your code and you're doing it all caps, I'm thinking, okay, why is an array in this? Because it should not be changed. Right? So that's just why it's both human and technical. Yeah. Yes.
They changed this for ES6, right?
ES6, yeah, ES6 now has a const declarator that you can use. Sorry, I'm trying to think. ES6 is, the const, I don't think you can change a const. I'm trying to think of what the scope for a const is, though, because, what?
I think there's a way to do it.
Yeah, well, so the way that ES6 changed things is I think const is still limited in your block scope. When we talk about scopes, I'll bring this topic up again. But the idea is like you can have a const within this one function, but then you may have another const outside of it that overrides it potentially. So that's why it may not be as strictly enforced as what it would be in. I want to say C does it, but I could be wrong about that. But anyway, just conventionally there's one thing, and then there's technical enforcement somewhere else. Any other questions? Okay, awesome. All right, let's take a 3-minute break. Go bathroom, get some water, whatever, and I'll get the next part of it set up for us.